The Marvel Universe is built on its own fictional laws of science that dictate how superheroes get their powers and wield them. The Ant-Man franchise is no different. A suit enables the main character to radically change in size, gain superhuman strength, control an army of ants, and much more.
The science behind Ant-Man. Physicist Hank Pym created a special suit controlled by Pym particles that allows a person to shrink down to the size of an insect. After his use, the suit and the title Ant-Man was passed on to Scott Lang. In his reduced form, Scott is enhanced by increased density as well as compressed energy and physical force. As a result, he can possess unnaturally high levels of strength, durability, and exertion capability. So how does Ant-Man relate to biology? Ant-Man's main superpower is the ability to shrink down to the size of an ant. The science behind scaling looks at how many of our biological functions, such as nutrient absorption and oxygen extraction in the lungs, are dependent on perfect proportionality. Most of our body's structures become imbalanced with any change in size, and if many of the different aspects are increasing or decreasing at different rates, the end result would be absolute confusion inside our bodies. Due to the mathematics behind scaling, Ant-Man's mass would decrease significantly more in comparison to his surface area, making it difficult to maintain a stable body heat. Maintaining a stable body heat is part of the process called homeostasis, which more importantly is one of the 8 characteristics of life. To supply his body with enough energy in order to maintain homeostasis, Ant-Man would need to consume his own weight daily, eating every second without sleep. However, if the change back to human size occurred rapidly enough, these complications with our biological functions would not be fatal.
Next up in the world of biology, let's take a look at the ants themselves. One of Ant-Man's key powers is his ability to communicate with and control ant populations. Ant-Man's ability to control the ants is only useful because of the unique abilities held by each type of ant. Let's dive into the capabilities of the different types of ants and how they're portrayed in the movie. First up is carpenter ants. Scott uses winged carpenter ants for transportation in the movie, which is plausible but extremely unlikely. Carpenter ants only have wings when they are sent out to start a new colony and never carry anything when they fly. The ants lose their wings as soon as they establish the colony. Scott would have to fly on a specific ant at a specific time, and doing so would disrupt the ant's mission to start a new colony. Next is fire ants. In the movie, a group of fire ants make a raft inside of a plumbing system, and another group construct a bridge for Scott to walk on. Both of these are entirely possible. In nature, fire ants have been observed to work collectively to create things like rafts and bridges. Next, bullet ants. Bullet ants are shown to have extremely painful stings in the movie, which they do. Bullet ants reportedly have the most painful insect sting in the world, with a rating of more than 4 on the Schmidt Pain Index. Last up is crazy ants. Crazy ants in the movie are loosely based on the tawny crazy ant, scientifically called Nylanderia fulva. In Ant-Man, these ants are described as being able to conduct electricity, which they can do, but not intentionally. These ants love to infest electrical boxes, and their bodies can form connections between electrical contacts in them, causing the boxes to short circuit. However, the ants have no way to control this ability, and most of the time, the electrical malfunctions are due to the ants chewing wires.
It means that you would enter a quantum realm.
What does that mean?
It means that you would enter a reality where all concepts of time and space become irrelevant as you shrink for all eternity.
In more scientific terms, the quantum realm, or the quantum parameter, in physics is a scale where quantum mechanical effects become important when studied as an isolated system. Typically, this means distances of 100 nanometers or less, or at very low temperatures. Well, science has it that as you go deeper and deeper into the quantum realm, the things that we take for granted, the idea that there are laws of physics, that there is a dimension of time, and we're moving through it in one direction, all of these things potentially dissolve. Reality itself is melting away, and new possibilities appear. For example, in the movie, the quantum realm is key for Ant-Man to time travel and save people. Furthermore, Ant-Man has the ability to talk to ants. According to the physics side of the power, talking to ants depends on the combination of finite, phenomenal, and electronical waves. The Antman suit itself presumably generates the pheromones and electrical aspects, allowing Antman to communicate with the ants. One of Antman's primary superpower is his ability to change his size, and this happens all with the help of the Pym particles. A Pym particle allows the user to change size, apparently by manipulating the space between atoms. For example, compressing the atoms efficiently means that you would shrink. On July 4, 2012, physicians in Geneva, Switzerland announced the discovery of the Higgs boson. This fundamental particle, long predicted to exist, is an excitation of the Higgs field that permeates all of reality. If we knew how to change the strength of the coupling between matter and the Higgs field, which we do not, we would be able to change the mass of any object, making it heavier or lighter at will. But in the movie, Henry Pym apparently not only discovered the existence of the Pym field through its corresponding Pym particle, but also how to vary the coupling between atoms and its surrounding field, thereby making them larger or smaller on demand.
This also relates to chemistry. When the Pym particle reacts to an atom, it changes the distance between atoms as well as increasing strength and density. That's why this happens.
When your small energies compress, so you have the force of a 200-pound man behind a fist 1/100th of an inch wide, you're like a bullet. You punch too hard, you kill someone. Too soft, it's a love tap. In other words, you have to know how to punch.
I was in prison for 3 years. I know how to punch.
Show me. Terrible.
You want to show me how to punch? Show me.
That's how you punch.
The average distance between bonded atoms is 10 to the negative 10 meters, or 1/10 nanometer. Decreasing the distance will result in an increase in density and strength, while exponentially decreasing the size of the object.
Computer science is primarily used in Antman in computer-generated imagery or CGI. CGI requires certain algorithms in order to create effects. Motion capture is one method in which CGI is created. It is a process of capturing the movement of a real object through markers and mapping it onto a computer-generated object. Specialized software and computer vision are used to record the actor's location over time as 3D coordinates, which is then used to create motion data. And this can also be done without markers, but this requires using matching software to track distinctive features of an actor, which is then mapped onto a virtual skeleton using motion building software. In Antman, this is especially useful because it can track Paul Rudd's motion, map it onto the Antman suit, which can then be grown and shrunk accordingly as Antman grows and shrinks. Furthermore, computer science is also vital for creating explosions in the movie. A technique called wavelet turbulence is used in order to do so. Wavelet turbulence is a software algorithm. It takes a low-resolution wave simulation and determines the location of missing high-frequency components. It then synthesizes these missing components using a turbulence function. This is used in Antman to generate realistic swirling smoke and fiery explosions easily and quickly.
Now let's explore what sports, health, and exercise science has to do with Antman. Antman is constantly running, jumping, fighting, and moving. As Antman is a human, he is able to do all of these things because of his muscles. The contraction of muscles which allows humans to move happens through the sliding filament theory. This theory begins with the muscle receiving an impulse from a nerve cell. This impulse goes to the center of the muscle fiber through transverse tubules, which are extensions of the cell membrane that lead into the skeletal muscle cells. Calcium is then released, which attaches to a protein called troponin. After the attachment, troponin changes shape, causing another protein called tropomyosin to move out of the way of myosin binding sites. Now that they are no longer being blocked by the tropomyosin, the myosin filament heads bind to the actin filament, creating a cross bridge. The myosin heads pull the actin toward the center of the sarcomere, causing the muscle to contract and shorten. As ATP binds to the myosin releases from the actin and slides back into the original position, causing the muscle to relax. Now that we know how muscles contract and generate force, let's take a look at how Paul Rudd built the necessary muscle to play the physically demanding role of Antman. He starts with a dumbbell bench press that works the pectoralis major, biceps brachii, and deltoids. He then does dumbbell bent over rows, which works the posterior deltoid, trapezius, latissimus dorsi, pectoralis major, and biceps brachii muscles. Next, he does V-ups, which work the rectus abdominis, external obliques, quadriceps, and hamstrings. He then finishes up the circuit with double unders, which work the latissimus dorsi, deltoids, gluteus maximus, quadriceps, hamstrings, gastrocnemius, and soleus muscles.